right, man. Speaking of which, you got a dollar today? I will bring 50 cents for every dollar.
Every day.
Alright, today we got transversals. What? Yeah, how can you prove and use theorems about angles formed by transversals that intersect parallel lines? We're going to prove and use prove and use theorems about the angles formed by parallel lines and the transversals. Our key term is transversals. What is a transversal?
Is a line that intersect at least two other lines.
A line that intersects at least two other lines.
You say intersects?
Intersects. It's the word that you see on the board right here. A line that intersects at least two other lines. Okay? So the most common transversal you're going to see is this one right here. You're going to have to know all the properties that go along with that transversal.
180.
180 will be involved many times. Okay? Up to and a cube many times. Alright?
Boom. Done.
You guys already got it. Down here, you've got more transversals. Okay? Now, what is the difference? What is the difference between a transversal on the left and a transversal on the right? They got that one going right up.
That goes through three lines.
These go, well, this goes through
That
two
one
lines.
has two parallel lines that intersected by one.
Parallel lines, parallel lines versus non-parallel lines. Those will produce different results. Okay? So that's what we're studying right now. What happens when a transversal intersects parallel lines? First thing that happens, we get, well, complementary and supplementary angles. You know what? You don't even need to write it down because you've already written it down today.
Let's go.
Unless you weren't here for the warm-up, because you're supposed to late. Okay, so make sure you got it written down. Complementary angles are angle pairs that have a sum of 90 degrees. Supplementary angles are angle pairs that have a sum of 180. That's why we got you up here, right, Philip? You know? Got it in my head?
I've gotten so much smarter.
Amazing what happens, okay?
It's true.
Check it out. Hey. They don't have to be adjacent. Wait, what?
What?
Wait, what? They don't have to be adjacent. Mr. Hobbs, time out.
What is
You
that?
kept showing me supplementary angles like this and this and this over and over again. You're right, I did. Today I'm going to expand your mind. I'm going to show you how.
Hey, you're married?
Okay? Yeah. She was crazy. Alright? I'm going to show you how 1 and 3 are going to be supplementary to each other. How about that? How about that? Okay? I'm going to show you how 1 and 5 are going to end up being supplementary to each other. Yeah, true story. We'll show you how today, okay? So you should have definitions of complementary and supplementary down. Does anybody still need this slide? Raise your hand. Yeah, I got Bright. Alright, so hopefully everybody knows complementary versus supplementary. Alright, now it's getting real. Vertical angles in linear pairs.
Oh, God.
You must know and recognize. You probably should put your literary analysis up, okay? Because, oh no, you will. Because you're going to know what vertical angles are, okay? Vertical angles, all they are opposite angles, right across from each other, okay? Here is an important fact you need to remember about vertical angles. Vertical angles are congruent. What's congruent mean? The same, okay? So in this example it says angle 1 and angle 4 are vertical angles. If angle 1 is 80 degrees, how much is angle 4?
80 degrees.
80 degrees. If angle 1 is x plus 4 and angle 4 is 80, what does that mean? That means that means somehow, yeah, angle 1 is 80 as well, right? They have to equate. Okay? You also need to know what linear pairs are. Linear pairs, as we learned yesterday in our linear supplements, okay? Linear pairs are supplementary angles that form a line. If they are supplementary, they have to add together to be how much?
180.
180. Check it out, guys. I got an array. You know what an array means? A bunch of linear pairs.
Correct.
1 and 2, does that form a line? Now Now look at it the other way. Tilt your head like this.
1 and 3.
1 and 3. Does that form a line?
Yes.
They are both supplementary angles. Okay?
What? I got confused.
1 and 2 is that's a pair. That's a linear pair, right? How many does it take to be in a pair? How about 3? No, it's 2.
Oh no!
Yeah.
That's three.
You know. A pair. Okay.
I said two
Right.
first.
What about 1 and 3? Is that a pair? Yeah. Does it form a line? Yeah. Then that's what we call a linear pair.
Sweet.
All right.
And then you got 3 and 4, 4 and 2.
You got 3 and 4. You got 4 and 2. You got the same thing down below. Okay. Everybody with me on this? So far, it's not bad, right? 4 and 1. 4 and 1 are what kind of angles?
Diagonal.
What do we call those diagonal things?
Okay.
Vertical angles. Okay. Those are called vertical angles. All right. Oh, let's get real. Let's get real with what we call corresponding angles.
I'm tired.
Okay? Corresponding angles. 2 parallel lines. Oh, wait. What kind of lines?
Oh, two
Parallel.
Parallel. Parallel. He's got it. Parallel lines cut by transversal. The pairs, how many? 2. The pairs of corresponding angles are congruent. What the heck is a corresponding angle? I do this every year, and every year it comes back to this to help kids recognize it. Okay? Look at angle 1 up here. Where is it located? Describe it to me. On the what?
left.
On the top left. Okay? If you want to know what angle corresponds with angle 1, look at the angles on the right, and you said angle 1 was top left?
Yes, that'd be
For the left? On the right, which angle is in the top
Third.
left? 3. That's corresponding. Okay?
That's easy.
So think about this to yourself. What angle, answer this on your own silently to begin with. What angle would correspond with angle 8? Answer it on your own. Think about it. Myrick, what you get?
Angle 6.
Yeah, 6. Bottom right, bottom right. That's all you got to do. Okay? Another way to think about it, if I took a picture of 1, 2, 5, and 6, slid that picture over here, correct? Whatever angles are on top of each other are the corresponding ones, right? Y'all know the old cut paste function? Sure y'all do, right? Crop function, right? If I crop this out and moved it over here, whatever angles would be sitting on top of each other are the corresponding angles. I don't adjust them, I don't move them, I don't have to worry about it. Corresponding angles, supplementary or congruent? What? Say it. Congruent. Corresponding angles are congruent.
I mean, I said that every one.
Okay? Alright, we got 3 more we need to know about. For right now, you don't have to worry about writing all this down, because we're going to do this about 1,000,000 times. Okay? Number 1, alternate interior angles. Here we go. Alternate interior angles. If 2 parallel lines are cut by transversal, what kind of lines must they be? What kind of lines? No.
Parallel.
They're parallel. If parallel lines are cut by transversal, each pair of alternate interior angles is congruent. That's great. Now the question is, what the heck does alternate interior mean? Here we go.
We're about to find out.
Check it out. I actually teach this the other way around. Interior alternate. Okay? Here's why. You recognize the parallel lines, correct? You'll see this? You go inside the parallel lines. You with me? 1, 2, 3, and 4 are inside the parallel lines. Alternate interior angles are inside parallel lines and on the opposite or alternate sides of the transversal. 1 and 3. Inside the parallel lines, on opposite sides of the transversal. 2 and 4, bless you.
Hey.
Inside the parallel lines, opposite sides of the transversal. With me?
So it goes like
Okay.
1 to 3.
Alright? Here's another way that I talk about this. Sometimes it helps. Who's ever played, and I know you kids were raised differently. Who's ever played Red Rover?
Oh, I didn't.
Play Red Rover.
Okay,
Let's see here. Evan, explain to me the basics of Red Rover. Pretend like I've never played before.
Object is to bust through a line of people that are chained together.
Perfect. The object is to bust through a line, right? An imaginary line, and then they hold hands, you know, Red Rovers, and Evan right over, right? And when this Red Rover game gets started, where are those two lines located?
Across from each other.
They're across from each other, right? You with me? Y'all with me? Y'all think I'm crazy. It works though, okay? If this was a Red Rover game, right? Alternate means they're on opposite sides. They're not on the same team, correct?
Right.
You got me? Anybody else making that? It's worked for years. Usually it works. Sometimes kids are like, I've never played Red Rover, and it wouldn't work.
It goes from 1 to 10.
Yeah, you see it? You gotta meet the criteria. Alternate means they're on opposite sides if they're playing Red Rover. They're on opposite teams, right? Y'all with me? Inside the parallel lines, interior. Okay? We'll go over this all again if that's not making sense to you, okay? You don't have to worry about it. Now we should just go play, right? Alright, hey, check it out. I also have, so that one's done. Next theorem. Consecutive, and they will call these same side. Same side. Yep. Interior angles. Alright. Y'all help me out here. Two parallel lines cut by a transversal. Each parallel lines are each consecutive interior angles are your supplementary. Hold on. Interior. Where am I going to look? Inside the what?
Parallel line.
So you gotta recognize your parallel lines and look inside. What is same side? What do y'all think that's gonna mean?
On the same side.
On the same side.
So 1 to 4 and
Okay.
2.
Remember playing our Red Rover game?
Makes sense.
You don't have to. I know, Gordon, you didn't play. Alright? Okay? I broke a kid's arm, so they had to make me not play.
Big Bill.
Yeah, I was a big kid.
What?
Alright, so, hey, here's an example. Cameron, you're gonna miss it. 3 and 4. Are they inside the parallel line? Are they on the same side of the transversal?
Yeah, because the
Yeah.
line.
See how it messes you up, right? You gotta look parallel lines inside, and then look at it the other way through by the lens of the transversal. Okay? I got one more. Alternate exterior angles. They are what?
Outside.
Outside. Okay, and they are on the opposite sides, right? You with me? Okay. Alternate, anytime you hear alternate, it's going to be congruent. How about it? Anytime you hear alternate, congruent. Alternate angles are going to be congruent. Anytime you hear same side or consecutive, it's going to be supplementary. Pretty simple, right? Okay? The problem with transversals is that we're going to end up with 7 different categories. Okay? And you've got to be able to categorize each of them. But I'll show you how to do that today. Let's go right into the Okay? Here we go. Check it out, guys. Alright. Hey, let me help you out here. I need to identify each angle pair. Okay? Identify the angle pair. 1 and 3, what are they?
Alternate exterior.
No, see, now you're off. See what happens to you? You get messed up with the whole alternate interior, alternate exterior, same side interior, and you forget about this. Hey Cameron, what do they form right there? A what? They form a 180, which is a what? Sublinear pair, right? It forms a line. It's a linear pair.
Oh, I got that right there.
Yeah. Okay, Cameron.
Sir.
I'll pick on you again. 3 and 6. What do you think now? Hold on. This is where we got to think about it. Where are the parallel lines? Here and here, correct? What do you think? Where are they? Where are 3 and 6? They're what? Inside. So you know it's inside. Are they on? Here's your transversal.
Alternate.
Are they on the same side or different sides? Different. Or alternate sides. Put it all together. Alternate interior angles. Alternate interior angles. Here's your parallel lines. Okay? You got me? Here's your parallel lines, like a sandwich. If you were thinking about it in terms of a sandwich, would this be something in the middle of the sandwich, or would it be outside the sandwich? If you were going to squish that, if you squish these parallel lines together, like this, would 6 get squished?
Yeah.
Yeah.
So
Then it's inside. Okay? Alright? You just gotta keep at it. 4 and 5. Alternate interior angles, right? That's just the other pair of alternate interior angles. Okay? Alright, what about 6 and 7? Allison, tell me about 6 and 7. Perfect. I like this. It's going through her brain. She's thinking, nope, that's not linear because it doesn't form a line. Hey, Allison, go like this with your hands. Perfect. Vertical, right? Those are vertical angles. All right? With me? Maybe?
Yep.
About halfway through it right now.
Oh,
Okay?
wow.
About halfway through it right now. All right? Whoa, what happened here? Oh, there we go. All right, here's what I want you to do. I want you to write down for me in your notes. I want an example of each. Okay? Write down for me an example of each. All right, here we go. Corresponding, I just gave it to you.
2 and 4.
1 and 3, 2 and 4,
5 and 7, and 6 and 8.
5 and 7, 6 and 8. Okay? Alternate exterior. Oh, wait a minute. Alternate exterior. Okay? What are the exterior angles? Let's go over those first. 1, 5, 4, and 8. Did everybody get, stop. Did everybody get that much? Y'all got exterior versus interior, I hope. Okay? You see that. Guys, exterior, if your lines are like this, whatever's on the outside. 1, 5, 4, and 8. So, of 1, 5, 4, and 8, what's a pair that's on different sides of this line? 5 and 4. What's the other pair going to be?
1 and 8.
Perfect. 5 and 4, 1 and 8. Okay? Alright.
Hang on.
Name me one linear pairs are the easiest. Do I?
They just said that.
No!
Wouldn't it be 2 and 6?
Yeah. Oh gosh.
Oh gosh, no. 6 and 7.
Where's the line here? 2.
I said 6 and 7.
1, 5. So when you think linear pairs, think about this. Just pick an angle. Pick any angle. Whichever angle is to the right of it and to the left of it, those are linear pairs.
So 1, 2, 5.
So no. How many is in a pair? It's the same question Philip had earlier. How many is in a pair? You don't have to look at him. You can look at me.
You just said that. No.
How many is in a pair?
I got you on that.
2. You ready? 1 and 2. And then 1 and 5.
Game over.
You're right. It should be game over. All right. What if I looked at angle 2 instead?
2 and 4 and 2 and 6.
Just go to the left. Go to the right. 2 and 1, 2 and 6. And we could do that with every single angle. Okay? You got it? It's like saying your next door neighbor. Or it's like, I don't even know how your houses are, so I'm not even going to get into that. Okay? Those are called adjacent angles. Right next to each other. Adjacent means right next to. Okay? Adjacent means right next to. Adjacent angles, they have to touch. Alright? They have to touch each other. So anything that touches you is considered No. Anything that touches you is considered adjacent, and adjacent angles form linear pairs.
I know the next one. 2 and 7.
2 and 7. Yeah, we did these. Y'all should know these already. 2 and 7, 3 and 6. 2 and 7, 3 and 6. Blue. Vertical angles. 2 and 5. 2 and 5. 1 and 6. What about the other pair? Yep. 3 and 8. 4 and 7. Okay. Okay. Let's get that down.
I don't like it.
That's okay. You don't like
Or
that.
then you could
Alright.
push up over 8.
Here's something you're gonna see today. Huh? What? Find each angle.
Holy
ECF.
crap, that's got numbers.
Oh man. Oh man. Hey, check it out. One, I'm gonna give you a lot of details about it, okay? One thing, no, you don't. Just watch. Just watch. Watch what happens when you watch. That right there is the key to everything. Okay? That right there is the key to everything. Here's why. I take that information. If that's 70, what's this angle?
70.
Hey? If those two are 70, what are these two?
But then what
Right?
about the?
Hold on, boss. We ain't done. We ain't done. Time out. Yeah. What do they have to be?
110, because you have to subtract
It's
70.
gonna be at 180. What?
These have to, this plus this has to be 180, correct? Stop talking.
Because they're.
Stop talking. This plus this has to be 180, right?
So you think you minus that?
This plus this has to be 180, right? These have to be congruent, right?
Yeah, sure.
I'm saying these and they're, you know.
So you don't even have to solve it.
Well, I mean, the only thing you've got to do, if you've got one angle, you can get them all. That's what's cool about these. Alright?
So there's
5x equals 110. What's 110 divided by 5?
110.
You have a calculator.
two. That's a good one.
Well, I got a question. How did you get 110? I'm so
No problem. I'll do
22.
I'll do addition for you in just a second.
22.
X equals
Say
22.
that first.
Okay? X equals 22.
Okay.
It's amazing, right?
I already
Okay?
said 22 up there.
Alright, how did I get 110? Very, very easy. Okay? And it's a principle that all of you need to hear. Alright? That's 70, right?
Yes.
That means that
You got to subtract it.
this, hey, this angle right there has to be a total of 180 because they're supplementary. It's a linear pair. Linear pairs are supplementary, right? Definition of a straight angle, 180 degrees, correct? Okay? X plus 70 equals 180. I'm not talking about that X. I'm talking about this, right? I tell you what, I'll make it question mark plus 70 equals 180. Solve for question mark.
110.
You subtract 70 from both sides. You're going to do this probably 1,848 times in the next 3 months. Okay?
You mean serious?
180 minus 70. 180 minus whatever. 180 minus your mom. 180 minus your dad. 180 minus your sister. 180. You will have this process down pat. I promise. Y'all couldn't define supplementary for me yesterday, and you went home, and now you remember it, right? Because you probably studied it. If you didn't study
90
it,
plus
you came back in, and you were like, "Oh, I got that down." Okay? Hey, they're not all easy. They'll be harder at some point, but watch how this works. Okay? Watch how this works. Again, I'll do this whole thing. Okay? Ready?
Oh, small.
If that's 118, what's this? They are vertical.
118.
Here's corresponding for you. These two are 118. These two have to be 118,
So
right?
then you gotta find 180 minus
62.
then divide it.
Don't need to divide it by
You
anything.
just said divide it last
62,
time.
62, 62, 62. I divided it last time because it was 5x.
So everything else
Okay.
is going to be 60.
Right.
What does it look like if it's gonna be 90 degrees? So,
Alright.
So everything will be 90? No, no.
Is that right
okay,
there?
so it's just across the thing?
Yeah, those are called perpendicular. I won't give it to you right now. Okay? Because it's a whole different set of rules. All right?
Then 180.
Guys, this is what I'm talking about when I say transversals. Your biggest thing is the small problems, not the big ones, right? You see what I'm saying? If you don't get that, here's what I mean. You know, putting all of this into a problem is not going to take you a long time. All right, now look at the question. QRS. QRS. How much is it? QRS. It's talking about that angle right there, which is 62 degrees. Okay?
So,
Got me?
If it's 90 with everything.
wait, can you give us some more of those signs by ourselves?
I will, but I'm going to show you a trick first. By the way, this is what some of it might look like. I'm going to show you the golden trick, okay? You will want to write this down.
I'm gonna get you.
It is time to get serious. We've gone through this whole thing. We've gone through this whole thing, and now you wait till the end to give me the golden nugget, right? I did. I'm a mean teacher. Here's your golden nugget. Anytime I have parallel lines, they have to be parallel, cut by transversal. I'll even show you this, guys. I could have 3 parallel lines.
No.
Y'all ready?
Yeah.
Y'all gonna be mad. when you
It's
see
only gonna
it.
be 2 degrees in the whole thing.
Nope.
Alright, go.
Well, yeah. You ready?
No.
Wait, give me a minute. Hold on.
Get Rex. Something you can let dog.
Those are vertical angles, right? Vertical angles always congruent, correct?
Yep.
Those are the corresponding angles to these two, aren't they? Hey, these are vertical, right? Those are corresponding, correct?
Yeah.
Corresponding angles are always congruent, aren't they?
Yeah.
These are alternate interior angles, correct? Alternate interior angles are always congruent. Thank you. These are alternate interior angles. Alternate interior angles are congruent, right? These are alternate exterior angles. Alternate exterior angles are always congruent, right? Y'all with me so far, right?
All congruent.
Look at that. Alternate interior, again, right? Corresponding again. Myrick, this is where your mind gets blown. Watch this. You ready?
Not real.
Alright, cool.
X always equals X,
Y always equals Y.
and there's one more.
And X equals
X plus Y always equals what?
X, Y. Oh.
If you do that right
Let's
there,
go.
if you get that down right there, this will be easy, breezy, beautiful, cover girl, geometry's a joke.
I like it.
Okay? That will be a joke for you.